Hi everyone, Mrs. Venti here. Welcome back to my channel. Today we are going to look at Euclidean geometry. Now, Euclidean geometry has got a number of theorems that we need to understand in order to use. Today we're going to look at exercise 1, and in exercise 1 we're only going to use theorem number 1. Which is new, but we also need to use all the previous knowledge that we know from geometry. So let's just quickly go over theorem number 1. According to theorem number 1, if you have a circle and there is a chord, remember a chord is a line from circumference to circumference that does not go through the origin. If it does go through the origin, it's called diameter. But if you have a line circumference to circumference, that is a chord. Now, if you have a chord and you have a line that goes from the center to the chord, you can have this definition. So remember, when we are talking about geometry, you have to prove something to be true. And the way we prove it is you look for one condition and we say, if this condition is true, then that is also true. And there's a reason for it. And on the screen, we have two separate statements, which are reciprocals of each other or inverses of each other or opposites of each other. So our first statement says, let's say you have a question and the question gives you a statement, like the statement says OB is perpendicular to AC. Now, how does this look? Look on the right hand side here by exercise 1, question A. It says here OB is perpendicular to AC. It's given to you in the question. So the question gives it to you. In the diagram, it's indicated by this perpendicular sign. So if they give me perpendicular, then I now know that AB is equal to BC. And my reason for that is going to be the line from the center is perpendicular to the chord. These reasons are the reasons that you are going to give to justify your answers. And these are going to be different. You're not going to give a reason theorem 1. Never ever write the word theorem. So you are now going to justify it saying the line from the center is perpendicular to the chord. Alternatively, if they give you the same sketch, but they don't give you the perpendicular line, instead of that, they give you a line that shows that AB is equal to BC. If AB is equal to BC, then OB is perpendicular to, OB is perpendicular to AC. So this is the theorem. So let's apply the theorem now to our first question. Question number 1 is on the sketch and we've already started working on it. And remember, you are going to write two things. You are going to write both a statement and a reason. So everything you write must have a statement and a reason next to it. So this question tells me that O is the center of the circle, OB is 6, OC is 10, OB is perpendicular to AC. Calculate the length of AC. All right, so I notice that I have a right angle triangle, which automatically I think Pythagoras. And in this right angle triangle, I notice that I have 2 out of 3 sides. So I can use Pythagoras. And what I'm going to say is I'm going to say that BC squared is equal to 10, which is OC, squared minus OB, which is 6 squared. So that is going to be 100 minus 36, which is going to give me 64. So BC is going to be the square root of 64, which is 8. So now I know that BC is 8. The reason for all that is the theorem of Pythagoras. Okay, so Pythagoras gives me that. I can make this argument because Pythagoras already proved this to be true. Now that I know that BC is 8, I can say that BC is equal to AB, which is equal to 8. And what's my reason for that? Let's go back to our theorem. If you have a perpendicular, you know that the lines are equal to each other. So my reason is going to be line from center is perpendicular to chord. Line from center is perpendicular to chord. Okay, have I answered the question? Not quite, because I want AC. So AC is equal to AB plus BC, which is 8 plus 8, which is 16. So AC is equal to 16 units. That's how you answer question A. Let's look at question B. Question B, they tell me that O is the center. EO is square root of 3. That's this line, which is square root of 3. And then they tell me to have colors. Let's try colors. OF is this one, and that one is 2. And then they want to know, they're saying OE is perpendicular to DF. And the calculation is, what is the length of D to E? DE. So that length, they want this length. That's the question. Okay, let's answer this. So again, I have a statement and I have a reason for that statement. I see right angle triangle, 2 out of 3 sides. I'm going to use Pythagoras. So I'm going to say that EF, which I don't know, EF squared is equal to hypotenuse, OF, which is 2 squared, minus OE, which is 3 squared. So EF is 4, sorry, this is square root of 3. 4 minus 3, which gives me 1. So EF squared is 1. EF is the square root of 1, which is also 1. My reason for all of this is Pythagoras. Now I know that EF is 1. I can make another statement and I can say that EF is equal to DE, which is equal to 1. And my reason for that is line from center is perpendicular to chord. Have I answered the question? Yes, the question wants the value of DE. DE is 1. That's how we answer question B. All right, let's look at question C. Question C, they're telling me O is the center of the circle. PQ and AB are chords. So this time I have 2 chords. I have OM, which is perpendicular to PQ. So this is OM and it's perpendicular. And it is equal to 5. So OM, not only is it perpendicular, but it's equal to 5. My next one is telling me that OC, which is this one, is perpendicular to AB and it is 7. My next one is telling me that AB, which is from here to here, is 48. So that's the third piece of information they give me. The question wants to know, what is the radius of a circle, of the circle? And the second one is, what is PQ? So I have 2 questions that I need to answer. The first one is radius, and the second one is PQ, and this is P, that is Q. So I want the length of that line. Okay, so how do we go about doing this? Let's start with radius. You know that the radius is a line from the center to the circumference. So if I was to doodle on this drawing, I could draw a line from the center to any point on the circumference. Make sure that it touches the circumference. And all of these green lines are all radii. The next thing that you know about radius or radii is that they are all equal to each other. All radii are equal to each other. So those are the 2 things we need to know about the radii. Okay, now that you know that, I am now going to remove all these green ones, and I'm going to ask you, hold on, I don't want to take that away, just the green ones, okay? Given what's on the screen, do you have a radius? A line that goes from the center to the circumference. Is there a radius? The answer is no, we don't have a radius. Can you draw one? Yes, of course you can. So now where are you going to draw that? How are you going to draw one? So let's do our radii. Let's change our color pen. Okay, let's go with blue. We're going to draw nice blue radii, and I'm going to use this ruler, and I'm going to go from the center, and I am going to go to that. So there's one. Let's make it nice and big. This is going to be my first radii. Why can't I draw? I want to draw. Stay still. Don't move. Stop moving. Nope. Go to the pen. Disconnect. Connect. I don't know why I can't draw. Stop. Okay, so this wants to measure but not draw. I don't understand why I can't draw next to it. Okay, that one let me draw. So let's try this here. Sorry. Oh, sorry about that. Okay, so let's see if it'll let me draw now. I want the blue pen. Come on, I need to draw. Blue pen. All right, I struggled a little bit with the pen, but I managed to draw a couple of radii. So what we said based on the definition is that AO is equal to OB is equal to OQ, and I'm going to draw this one without a ruler, is equal to OP, because they're radii, right? I haven't answered the question yet. We're just thinking logically. So if I input the radii, then I can create right angle triangles. So I want the red line PQ, but in order to get there, I am going to use the pink line and the green line, and then move from there to the red triangle. Now, why am I going to start on the pink line? Because I need 3 pieces of information, 2 known and 1 unknown. The one thing that I want to know is, what are the blue lengths? Question number 1, what is the length of the blue lines? So let's use triangle AOB, but no, we can't use AOB because that's not a right angle triangle. So let's use COB. So if I use COB or COA, whatever, the question now is, I know that OC is 7, but what is AC or BC? And that's going to be our first statement. So our first statement is going to be reason. Our first statement is going to be that AC is equal to BC, which is equal to half of 48, right? And why is that? My reason is I have a perpendicular. So let's go back to our theorem. The theorem says if they give me a perpendicular, then I have equal lines, right? So line from the center of the chord is my reason. Line from center of the chord. Line from center is perpendicular to the chord. Line from center is perpendicular to the chord. Okay, so that's my reason. So now I know that AC, which equals to BC, which is equal to 24. Okay, so now I know this is 24 and this is 24. 24 and 24 makes 28. So now I've got my first step towards Pythagoras. So now I can say that OB, which is my hypotenuse squared, is equal to 7 squared plus 24 squared. And then I put that into my calculator. So I'm just going to open up the calculator now. So 7 squared plus 24 squared equals 625. And the square root, okay, let's clear that. Square root of 625 is plus minus 25. Okay, so now I know this is going to be OB squared is 625, and OB is the square root of that, so that is going to be 25. I only do plus because it is a length. Lengths are positive. So OB is 25. And that is the answer to question number 1. Question number 1 says radius and what is PQ is question number 2. OB is the radius, right? So now if OB is 25, then OQ is 25, and OP is 25, and AO is 25. All of them are 25. What is the length of PQ? So now I'm going to be in my second triangle, right? I'm going to use the red one, and I'm going to make a statement, and I'm going to say, I can use the triangle 25, 5, and MQ. Okay, so now I'm going to say MQ squared. Oh, I forgot to write something up here. This whole section is due to Pythagoras. Please don't forget to write your reasons. That is Pythagoras. Okay, so that's Pythagoras. Let's go back to the bottom. OM squared is going to be, so OM is from here. Sorry, not OM. Let's redo that. MQ. MQ squared is equal to 25 squared. That's the hypotenuse, minus 5 squared. So 25 is 625 minus 25, right? 5 squared is 25. So that gives me MQ is a length of 600. MQ squared is 600. And MQ is the square root of 600. Let's look at that. So square root of 600. 600 is 10 square root 6. Okay, so that is 10 square root of 6. That is the answer to the first. So this is 10 square root 6. So now we know all of this was due to Pythagoras. Now we want to make a statement, and in our statement we want to say MQ is equal to PQ. MQ is equal to PM, which is equal to 10 square root 6. Are we in agreement? And the reason for that is line from center is perpendicular to the chord. So now that I know that PQ, which is the answer I want, is equal to MQ plus PM. So that is equal to 10 square root 6 plus 10 square root 6. Now what happens when we add surds? Very good question. So on our calculator, you can input 10 square root 6 plus 10 square root 6. Oh, what happened here? Everything's under the square root, so be careful. Go out, plus 10 square root 6. And your answer is 20 square root 6. So this is the same as saying 10x plus 10x. The x's remain as just 1x, and you end up with 20x. So your answer here is going to be 20 square root 6 is the answer for PQ. So that is question C. In this video, we have covered theorem number 1, question exercise 1, question A, question B, and question C. Next video, we will continue. Please click on the like and subscribe, and I'll see you in the next video. Bye-bye.